We're going to continue from yesterday with factoring. We're going to do a little bit more. We're going to do some harder problems today. But let's start like we started yesterday with classifying the problem, right? You have to be able to tell me what type of problem it is or tell yourself what type of problem it is. If you're looking at this, this looks like a hard trinomial, but you always want to look for a GCF first. All three of those numbers are divisible by 3. This one's an easy trinomial. Get used to that pattern. This one looks like the same thing, GCF, but all three of those numbers are not divisible by 3. That one must be a hard trinomial, and that's what we're going to talk about today a little bit. Difference of squares, you're looking for a subtraction problem with two things you know the square roots of. This is two things, but it's not a subtraction problem, and I don't know the square roots. It's definitely not a trinomial. This one is a GCF. Both of those numbers are divisible by 3. This one, that's another easy trinomial. I think most people are pretty good at recognizing that one, but some of the other ones kind of blend in. To me, when you see one that just looks different, it's probably going to be a GCF. So get in the habit of always looking for a GCF first. This one, definitely a GCF. Anytime it looks really super complicated and weird, probably going to be a GCF. This one, hard trinomial. And this one, difference of squares, Okay, so we've got to be able to classify those problems so we know how to attack them. Again, why we're doing what we're doing is we're trying to get to problems that we can solve that we couldn't solve by isolation, isolating the variable. We're not going to be able to isolate any variables if we tried to solve equations like this. So let's review GCF, easy trinomial, and difference of squares. This is kind of what we talked about in the last lesson. This one, number 1, is an easy trinomial, and that's the one where you say, give me two numbers that multiply to 32. So I list them all out. 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, done. Okay? So we're looking for two numbers that multiply to 32 and add up to 12. Well, that's these two numbers right here. So we're going to say x plus 4, x plus 8. That's factored. Factored means write it as multiplication. Something times something else. So something times something else, there's your multiplication symbol. This times this, that would be your answer. Number 2 is a difference of squares problem. Difference of squares problem also splits into two binomials. And if you want to think about it as an easy trinomial, I suppose you could if you put a 0 in the middle. You need two numbers that multiply to -4 and add up to 0. But if you recognize difference of squares, you're just going to take the square root of 4 as 2. It's going to be x plus 2 and x minus 2. Number 3, that's an easy trinomial. So an easy trinomial splits like this. X times x is x squared. We need numbers that multiply to 40. I'm going to ignore the negatives for a second and just look at 40. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work, done. I need two numbers that multiply to -40. So I know one of the two numbers is negative. All right. But now they're going to add up to +6. So you've got to think about that negative. One of those numbers has to be negative in order to multiply to -40. And then they're going to add up to 6 or subtract to 6. Sometimes it's easier to think about subtraction. You might say, well, 10 minus 4 is 6. That's going to do it. -4 times 10 is -40, and -4 plus 10 is +6. That's it. X minus 4, x plus 10. Got it. All right, so number 4, also an easy trinomial. Two numbers multiply to 7. Well, it's just 1 and 7. That's it. That's the only possibility. All right, sometimes people get tricked by the ones with a 1 on it, like this one, but you just have to treat it the same way. We're multiplying to -7. That means one of my two numbers is negative, but if it's going to add up to a negative, think about it. This one's got to be negative. +1 minus 7 is -6. +1 minus 7, like this. All right. So let's just do a couple more. I don't want to do all of these. Number 5, that's not a trinomial. There are only 2 terms. It cannot be an easy trinomial. It is not difference of squares because of this a. I know we know the square root of 4, but we don't know the square root of 4a. This is a GCF. You should always, always, always look for a GCF first. If you can do a GCF, that's going to be a lot easier than hard trinomials that we get into. But I look at both of these terms and say, well, both of them have an a in it. So I write down an a, and then I think about what would I multiply by to get back to where I started. Well, a times a is a squared. There's going to be a minus sign, and a times minus 4 is going to get me that minus 4a. That's factored. It's factored because it's written as times. This times this. That's factoring. All right, so we could do more, and they get kind of complicated, I suppose. I guess let's do number 6. Number 6 looks complicated. It looks hard, but notice there's a GCF. There's something in common. All 3 of these terms are divisible by a 2, and also they all at least have 1 p in them. And so I would factor that out, and then I would write in parentheses behind here what's left over. Okay, think about multiplication. 2p times p squared minus 2p times 2p would give me 4p squared, and then minus 2p times, what would that be, 80? Right there. And what ends up happening in this problem is I've transformed the problem from a GCF problem. This had a GCF into an easy trinomial problem that I'm going to have to do another method. Okay, so we've got this 2p in the front, but now I'm going to have to change this using my easy trinomial method. There's a p and a p. I need 2 numbers to multiply to 80. Sometimes you just see it. Sometimes you don't have to write these numbers down, but when you ever get stuck, write them down. 5 and 16, 6 doesn't work, 7 doesn't work, 8 and 10. That's it. Okay. So they have to multiply to a negative, which means one of the numbers is negative. They're going to add up to negative 2. That means this one, negative 10. Plus 8 minus 10. Got it. I did a GCF and an easy trinomial. Let's do one more, number 10. Number 10, for some reason, that tricks everybody. But you always look for a GCF first. Both of those have a b in it. And so in parentheses, we write down what else would have to be. B plus 1, very good. B times b is b squared, plus b times 1 is b. A lot of people miss that one. A lot of people forget about the plus 1, or they just think, well, it cancels and it's gone. It's not gone. All right, it's b times 1 is b. Now, we haven't done any hard trinomials yet. Let's look at hard trinomials. Students really struggle with this, and there are other methods of doing this, but I'm going to show you what I think is the best way to do it. It's the best way to think about why the numbers are the numbers. So when I look at number 1, I really want there to be a GCF because these numbers make it hard. It's either a GCF or it's a hard trinomial. It looks like an easy trinomial, but the thing that makes it not an easy trinomial is that 7 in the front. That 7 really complicates the issue. So the good news is, I suppose, we're going to treat it like an easy trinomial. So we're going to put it in these parentheses like this, okay? But I wouldn't write x and x, because if you multiplied x times x, you get x squared. We need to multiply them and get 7x squared. So I'm going to write 7x times x right there. 7x times x is 7x squared. I've got to write down what the multiplication problem would be to get me back to the start. So right now I know I've got 7x squared covered. I'm going to do this very similar to how I did the easy trinomial. I'm going to look for 2 numbers that multiply to 30. 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. Okay. Now, what you should notice at this point is those numbers do not add up. You can't add those numbers up to get 47. Those numbers will not add up to 47, all right? And they shouldn't because of that 7 in the front. If you think about multiplying this out and distributing, 7x times x is 7x squared, and then you'd have 7x times whatever this is, and we could continue our distributive property, whatever. It would look like that, you know, if we multiplied that out. The point is, whatever goes right here is getting multiplied by 7, all right? So what that means is when we look at our numbers, one of these numbers is getting multiplied by 7, and then they'll add up to 47. So that's kind of tough, and so that's why I would recommend you have a calculator. You write this list down. So a lot of the times I find that people that don't write this list down really struggle. So write it down, look at it, and you've got to try to figure out, how can I multiply one of the numbers by 7 and then add up to 47? And so if you look at it, 6 times 7 is 42, plus 5 is 47. That's going to be the way to go. Okay, that's going to be the way to go. So my two numbers are 5 and 6. But the 6 has to be in the position getting multiplied by the 7. All right, that's really tough for some people. And this number right here is going to be a 5. That's factored. Factored means write it as multiplication. When we've got something times something, we are factored. That's factored. Now, I know that's hard. That's why I want to do a couple of examples here. Okay, this one is a hard trinomial, but the first step is easy. First step's easy. It'll be 3p and p to make 3p squared. But after that, we have to look at the numbers. 32, 1 and 32, 2 and 16. 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, done. None of those numbers add up to 28, but they won't. And they won't because whatever number is over here is getting multiplied by 3. So what you have to do is you have to think about, how do I multiply one of the numbers by 3, and then they'll add up to 28. Does anybody see it? You've got to be good at your times tables. Eight times 3 is 24, plus 4 is 28. Okay, that's how it is. All right, that's how it is. So that means that my 8 has to go over here, and my 4 has to go over here. You have to put the 8 in the position that's getting multiplied by the 3. If you switch the two numbers around, it's not going to work right. It's not going to work. All right, so let's do another one. 7x and x. All right, that's the easy part. I need a 60, so 1 and 60, 2 and 30, 3 and 20, 4 and 15. 5 doesn't work, 6 and 10, 7, 8, 9 don't work. None of those numbers add up to 52. But that's because one of them has to get multiplied by 7. This one. You got it? 7 times 6. 7 times 6. 7 times 6 is 42, plus 10 is 52. It's tough. That's tough, but this is the best way to do it, okay? If you're confused right now, you are normal, because it's really hard to see at first. But once you see a few of them, you're like, oh, okay, I can do this. So 7 times 6, that means a 6. The 6 has to go here, and the 10 has to go here. The 6 has to go in the position that's multiplied by the 7. Next one. I bet you'll get this one. 2x and x. Need a 40. So 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work, done. One of the numbers has to get multiplied by 2. Two times 20 is 40, plus 2 is 42. Try something else. You got it? 8 times 2 is 16, plus 5 is 21. So that means the 8 has to go over here, and the 5 has to go over here. That's it. All right, once you figure that out, once you get it, it becomes obvious. But man, it takes a while. It takes a while, and that's why I'm doing so many examples. All right, so let's do one more, and then we'll switch gears. 3x and x. The smaller the numbers, the easier it is, I think. 8 is 1 and 8, 2 and 4. How can I use that 3 to make a 10? Three times 2 is 6, plus 4. Right, so that means the plus 2 goes over here and the plus 4 goes over here. All right, that's how it works. Now, it's definitely going to be harder once you start throwing in negative signs. You've got more things to think about. And once you, sometimes the non-prime numbers make this harder, but let's switch gears over. Okay, so let's go to here. So factor each completely. Now, on this sheet, it might be a hard trinomial, but don't forget about your easy trinomial and your GCFs and your difference of squares. We want there to be a GCF. I don't see a GCF though. This must be a hard trinomial. 7m and m. 7m and m. So we're going to list out ways to multiply to 4. And trust me on this, guys. If you're struggling, write this out. Okay, it's going to bug me if you're struggling and don't write this out, because this is really powerful. It really helps to be able to see those numbers pop out. All right, those numbers do not add up to 11, but I bet they will once you multiply one of them by 7. Do you see it? You can just kind of play around and say, well, if I multiply this one, that's going to be 14 plus 2 is 16. That can't be right. If I do this one, that's 28 plus 1 is 29. That can't be right. If I do this one, 7 times 1 is 7, plus 4 is 11. There we go. That's it. That's the one. That's the one that works. So we put the plus 1 over here because that's the position that's getting multiplied by 7. If we distribute, if we multiply. 4 right there. All right? So number 3 is a lot harder. Okay? And it's a lot harder because if you're looking at how to get 10, it could be 10a and a, but there's another possibility here. It could also be 5a and 2a in either order. So that doubles the number of possibilities we'd have to look at. We have to look at extra things that could happen. Now, luckily, 6 doesn't have a whole lot of options here. But we have to figure out which one of the two ways works. Either we multiply one of the numbers by 10, or we have to multiply one of the numbers by 5 and the other number by 2. One of those ways will work and one of them will not work. So we can just kind of play around and say, well, times 10, that's going to be 10, 16. That's not going to work. Okay. Over here, that'd be 61. That's not going to work. Over here, that's going to be 23. Nope, that's close. Over here, that's 32. None of those work. So that tells me that that possibility isn't going to work at all. I know it has to be 5 and 2 now. Okay, so what you'd have to do is kind of play with both of those numbers. One of the numbers gets multiplied by 5 and one of them by 2. So if I go 5 and 2, 5 times 1 is 5. 2 times 6 is 12. That's 17. That doesn't work. 3 times 5 and 2 times 2, that's going to be 4 plus 15 is 19. Okay, we got it. Good. That works. There's only one way that this is going to work. Now, you got to be careful, because you have to put, if you think about the way distributive property works, 5a times 2a is 10a squared. Good, got that one. But 5a times this number, well, that means I've got to put the 3 there. 5 times 3. So make sure you put the 3 there. And then we distribute, this one's the 1 times 2. So 2 times 2, so right here. And then this times this is how I get the 6. The first term and the last term are easy. It's the outside and the inside. And so how I would check, sometimes how I'll check my answer, is I'll call it the OI. If you multiply these two, you get 15a, and these two, so the outside and the inside of FOIL, that's 15a plus 4a is 19a. That's kind of how I check in my head. I'll just use my fingers and say, well, these two are 15a and these two are 4a. 15a and 4a is 19a. Okay. Let's skip 5. Let's go to number 7. Number 7. Since 5 is a prime number, we know it has to be 5k and k. There's no other possible thing. We need a 60. So again, I ignore the negative for the time being. I'll go back and look at that later. The faster you are at this, the better. 5 and 12, 6 and 10, 7, 8, 9 don't work. Okay. Need to multiply one of the numbers by 5, and then they'll make a 44. Oh, wait, one of them's negative. This makes it harder. One of the numbers is negative. So multiply one of them by 5, and then they're going to add together to make a negative 44. No, I don't see it. 5 times. Does anybody see it? Worst case, you can just kind of plow through. Times 5, that's going to be 5 plus 60 is 65. That's not right. Times 5, that's going to be 301. Nope. Times 5, that's 10. That's 40. Nope. Times 5, that's 150. Times 5, that's 15, and 20 makes 35. Times 5, that's 100. No. Times 5, that's 20. No. Times 5, that's 75, 71. No. Times 5, that's 25. It's 12. Nope. Times 5, that's 60 minus 5. No. Times 5 is 30. No. Times 5 is 50. There we go. Finally got it. If we do 50 minus 6, that's 44, right? 50 minus 6 is 44. Oh, wait, but I've got the signs wrong. I don't want 44. I want negative 44. So we're going to do negative 50 plus 6. I've got negative 50 plus 6 is negative 44. That was a hard one. I had to really think about that. So put the negative 10 over here because that's the position that's getting multiplied by 5. And a plus 6 right there. Sometimes these are a lot easier than other times. That one was a hard one. I think number 9 will be a little bit easier because of the plus signs. The negative sign really complicates the issue. Number 9 does have 2 possibilities, though. Because 6 is not prime, you have to look at one of these 2 possibilities. I need numbers that multiply to 15. 1 and 15, 3 and 5. So you can just play around. 6 times 1, that's 6 plus 15 is 21. That's not going to work. 6 times 15, that's way too big. 6 times 3 is 18, plus 5 is 23. 6 times 5 is 30, plus 3, nope. I don't think that one's going to work at all. So we try the 3 and the 2. The 3 and the 2 means one of the numbers gets multiplied by 3 and the other one by 2. So if this one's 3 and this one's 2, that's going to be 3 plus 30, that's 33. No, maybe this one's 2 and this one's 3. That's 2 plus 45, that can't be right. Maybe this one's 3 and this one's 2. That's 9 plus 10 is 19. There we go. Got it. All right. Got it. 9 plus 10 is 19. So put the 3 over here in the position that's getting multiplied by 3, and put the 5 over here in the position that's getting multiplied by 2. My check is this. That's 9p plus 10p is 19p. That's all I do as a check. Okay, I do it really quickly with my fingers. It's 9p, 10p, That's 19p. Done. Number 11. Do you notice this is an easy trinomial, not a hard trinomial? That's kind of the first step here. They're not all hard trinomials. This one's a lot easier to do because we don't have that extra step to worry about. It's 2 and 9, 3 and 6. This time, all we have to do is find the combination that adds up to 3. I know one of the numbers is negative, so we need to find the combination where one of them's negative, and then they'll add up to 3. Negative 3 and positive 6. Negative 3 and positive 6. That was an easy trinomial. A lot less to think about that time. Number 13. That's not a trinomial. It can't be an easy trinomial. It can't be a hard trinomial. It's got to be a GCF. And sure enough, both of these numbers are divisible by 6. I know that's kind of hard to tell. 216, you probably don't know your multiples of 6 or whatever, but 216 is going to be divisible by 6, I bet. $36. I'm going to factor out a 6. Remember, that just means write it as multiplication. 6 times x squared minus 6 times 36. That was a GCF. But check it out. At this point, I now have a difference of squares. That's a difference of squares. Square root of 36 is 6. So we're going to have the 6 in the front. And then my difference of squares is going to go x plus 6, x minus 6. $15. GCF. Both of those numbers are divisible by 6 and an n. Both of those have a 6 and an n in them. So think about how to multiply back. 6n times n, 6n times 7. That's factored. And it's factored because it's written as multiplication. Next one. Looks like a hard trinomial, but it'd be nice if it was a GCF. Are all three of these numbers divisible by 5? They are. They're all three divisible by 5. 95 divided by 5 and 450 divided by 5. This is going to be a GCF problem. GCF. So write down that 5 as your GCF. 5 times a squared minus 19a plus, what was it? 90. I did a GCF. But now I've produced an easy try. So now I also have to do that easy try on here. Two numbers are multiplied to 90 and add up to negative 19. Okay? 9 and 10, right? Both negative. Very good. Sometimes you can just see it and you don't need to list out all of those numbers. If you can just see it, you just write it down. Last one. What pattern is that? Easy trinomial. R and R. Two numbers are multiplied to negative 21 and add up to positive 4. Plus 7 and minus 3. Plus 7 and minus 3. That's it. That's factored. That's finished.